Okay, good morning. Today we are continuing on with our chapter 2. Let's go over those vocab words again. Our first one is petroglyph. What is the petroglyph, Katie? It's a rock carving made by people. Not by the glaciers, not by animal claws, but by people. What is an elder? Nathan.
Someone who is older but is respected for their wisdom.
Someone who's older and is respected for their wisdom. So looking at your culture, who are the older people that you go to for advice? Archaeologist, Cole.
A person that studies fossils and caves.
So the person who studies things of the past. So it's not just studying fossils. They're not a paleontologist who's studying the dinosaurs. But the archaeologist studies the past. They study history. Perspective, Joseph. Sorry, say that again.
Someone's point of view.
Yeah, somebody's point of view. So it's a person's point of view. So there are a lot of perspectives out there. We have right now 27 people in this classroom. So there are 27 different perspectives about what's going on. So it's your individual views on things. Oral history, Maddie.
The retelling of stories about past events and of the group to teach about the group's culture.
Yeah, the retelling of stories of past events, and it all pertains to your culture. So if I were to tell the story of Goldilocks and the Three Bears, is that oral history of Minnesota? No, because Goldilocks didn't live in Minnesota. It has nothing to do with Minnesota. It's a great story, but it's not oral history for us. If I tell the story of Paul Bunyan, is that oral history for us? Yeah, because Paul Bunyan is from Minnesota. He's that lumberjack that's talking about that part of our history and the importance of the lumber industry in Minnesota. Artifact. What is an artifact, Jocelyn?
Any object made or used by humans.
Yeah, it's any object made or used by humans. So it's those physical things, the objects that you can touch, that it's either made by people or it's used by people. What is the scientific method? We have not talked about this yet. What is the scientific method, Izzy?
The process using experiments and careful observation to test ideas and theories.
Good. It's the process using experiments and careful observation to test ideas and theories. So it's that special way to test out and see if what you came up with was correct. And our last one is the hypothesis. What is a hypothesis, Leah?
Like a guess.
It's an educated guess. So you have a good idea that this might be the answer. Okay. Whenever you have that good idea, is it fact? Is it this is the answer? No, it's that educated guess. I think this is going to be the answer. Then you do the scientific method to check and see. Today we are going to be on page 18. Yesterday we stopped on the top of page 18 with the oral history. So today we're starting on the bottom of page 18 with another way of knowing. We know a lot about our past from oral history. Another way of knowing about the past is archaeology. So open your books to page 18. And because I'm recording, I'm going to do the reading from up front so it'll come across clearly. Archaeologists study many types of physical evidence or artifacts. One type is the petroglyphs, like the ones found at Jeffers. To an archaeologist, the Jeffers carvings contain information that can help answer questions such as who made the carvings? Where did the people who made them come from? Depending on the questions they have, archaeologists use different methods to uncover information. One common method is to compare an artifact archaeologists have questions about to an artifact they have already studied. Sometimes, though, the answers are not easily found through comparison. Then, archaeologists may conduct experiments instead. So sometimes if you have an arrowhead and you've already studied it and found all these conclusions, and then you find another arrowhead, you can compare them and figure out stuff about the new arrowhead based on what you know about the old one. But sometimes when you're comparing, it still doesn't answer your question. So then you might want to run an experiment. Archaeologists at Jeffers recently conducted an experiment to find out how long it may have taken to create a hand petroglyph. In doing this, they used a process called the scientific method to test their ideas. The scientific method involves developing a hypothesis and conducting an experiment to test it. The scientific method includes 5 basic steps, which the archaeologists at Jeffers followed to help them understand the hand petroglyph. So what's the first step they have to do, Finn?
Step 1, ask a question.
What is the question they're asking? Maddie? Oh, don't look at your book, guys. Think about it. Think about what we were talking about. What question was the scientist, the archaeologist asking?
What does the handprint?
Say that one more time.
What does the handprint?
That is a question that we have talked about, but that's not what they're running the experiment on. Nick?
What happened here?
What happened here? A little bit more specific, Briggs.
How long it would take to carve?
How long did it take for them to carve that handprint? So it's a very specific question. How long did it take? So what's step 2 of our scientific method? Will?
State a hypothesis.
Yeah, their hypothesis. Don't look. No spoiling. How long do you think it would take to carve out a handprint? Thinking back, this was 7,000 years ago. So this isn't using your tools that Dad has out in the garage or Mom has in her toolbox. It's not using those specific tools. It's using something they had available 7,000 years ago. Izzy?
Maybe 2 to 3 hours.
Okay, maybe 2 to 3 hours. What do you think, Cole?
1 hour, and they would use a rock.
Okay, so Cole's thinking, I think it would take an hour if they use a rock to carve it.
So it would be like a shovel.
Yeah, so a sharpened rock, so that's kind of like a chisel. Nathan?
An hour about.
Maybe an hour. Leah?
They could use like an arrow.
Maybe they're using an arrowhead because we know it's got that sharp point on it to chisel. How long do you think it would take with that arrowhead?
Probably.
Maybe an hour. Kira?
I think to get a very a perfect hand would be like an hour and 50 minutes.
Okay. Maddie?
3 hours.
3 hours. Katie?
Probably 3 hours because they have to get the supplies they need.
Yeah, they need to get all the supplies. Joseph, what do you think?
Maybe like 45 minutes.
45 minutes. Nick, what are you thinking?
I'm thinking about a day.
A day? Because that quartz that they're carving into is pretty hard. So it's going to take a lot of muscles to carve that. So maybe it's going to take them all day. Will?
Maybe 4 to 5 hours.
44 4 to 5 hours. All right, let's see. Oh, other Will?
5 hours.
5 hours. All right, so let's see what happens. Step 1, ask a question. The quartzite rock on which the petroglyphs are carved is very hard. It seems like it must have been difficult for people without modern tools to make carvings. Since so many people are fascinated by the handprints at Jeffers, it's natural to ask how long did it take the Jeffers rock carvers to make a handprint. Step 2, state a hypothesis. A previous experiment found that it was quite easy to make chips in quartzite by hitting it with another type of stone found in the region. With that knowledge, the archaeologist made an educated guess, a hypothesis. It would take several hours to carve a handprint like the one found at Jeffers. So they're saying several hours. I would say 2 to 3 hours would be several, maybe 4. Step 3, perform an experiment. The archaeologists decided to find out if their experiment was correct. They carved their own handprint and recorded how long it took. First, they painted the image of a hand on a quartzite slab. So how do you think they painted their hand? Did they open up a paint can, put it on their hand, and put the handprint down? Cole?
No, they could have used I don't know. I think they could have used chalk because you had big rocks together. Sometimes it can make like a gauge.
So maybe they made a chalk dust by banging the rocks together, because back 7,000 years ago they didn't have paint cans. So they would have to use something that the people at Jeffers actually used. So maybe they made chalk to do a chalk handprint. What do you think, Leah?
They could have like had some put their hands on and like make an outline first and then
Maybe they made an outline using like charcoal. What do you think, Katie?
I think they might have found some berries or something.
Maybe some berries. We all know how much blueberries can stain. Maybe they use the juice of the berries to put on their hands. Finn?
they could have used like some colored clay.
Maybe colored clay to make the outline of the hand, or
Mash it up.
mash it up. Oh, if they kind of like what Cole was saying, if they get the dust of the clay and it's got that color to it, that would work. Izzy?
They could have used mud.
Maybe mud. So maybe they put mud on their hand and put that on the rock. Okay, we've got lots of ideas of what they could have used. Let's keep on going. So after they put the handprint on, then they found a piece of stone that they could use as a simple hammer. They recorded their start time and then started hitting the quartzite slab over and over again with their stone tool, following the outline they had painted. A carved hand began to appear. Step 4, record the findings. When their carving finally looked like the handprints found at Jeffers, the archaeologists checked their clock. They discovered that it had taken them just 42 minutes to make the handprint. So that was pretty quick. Step 5, reach a conclusion. The archaeologists found it was fairly easy to carve a handprint into quartzite using a simple stone tool. Since they were able to complete the handprint in 42 minutes, their results showed that their hypothesis had been too cautious. The archaeologists concluded that people who made the Jeffers petroglyph could have carved a handprint in less time than the archaeologists originally predicted. So think about how there were thousands of handprints found at Jeffers, which is pretty impressive to see all of those carvings. It didn't take that long for them to make the carvings. So the people that made the carvings, it wasn't a day-long affair. They were able to make those carvings and to speak their stories through the pictures fairly easily. Katie?
Yeah, what didn't they say that they found 14?
14
handprints.
handprints. But think about all the carvings, because there's thousands of carvings that they found there. 14 of them were the handprints. But think about any of the shapes that we've seen and the pictures that we've seen. They just had to draw it first and then chisel it out.
They seem to have like more like outlines and stuff, not carving all the way inside of it.
I think you're right. I think some of those pictures were more of like an outline, which would probably be even quicker than doing a handprint where you have to chisel out the inside of it. So just doing those simple pictures of the outlines probably went a lot faster. Nick?
Couldn't they also use flowers and leaves for paste to make the outline?
Yes, that would have worked for the outline too. Do we know for sure what they used? Nope, we don't know for certain, but we can make some educated guesses, have a hypothesis on what they used. Maddie, or Izzy?
What if maybe it would have taken a shorter amount of time for them since they need to do it more often versus the archaeologists made them?
That's a very good point. If they've made several carvings already, they know exactly what to do and how to do it. And we know that once we do a task over and over again, it goes quicker and quicker. So it probably took them a lot less time to carve because they were used to doing it. Katie?
I think maybe just for fun, the kid might have done one. Sure.
Yeah, there might have been kids that were carving it if they knew what to do. Remember, that was part of the education that they got back then, was how to live their lives. So maybe part of it was somebody teaching their child how to do the carvings so it could live on, so they could go to the next generation to be able to do the carvings. Do you have any questions about the experiment that they conducted at the Jeffers site? Do you think that if we were to do, based on the information they gave us in the book here, would we be able to recreate this experiment exactly and come up with the same result?
No.
I have some people saying, well, yeah, they told us what they did, and some people saying, not quite. I don't think we could do it exactly. Who was one of my friends that said no? Finn, why could we not do the experiment the exact same way?
Well, because we're kids. And,
Oh, that doesn't
then
matter.
we should be playing with rocks.
Kids play with rocks all the time, Finn. It doesn't matter your age. Shh. Doesn't matter your age. You should be able to follow the experiment and recreate the experiment. What problems might we have, Zoe?
Well, different people would do different things different ways, and then maybe we could use like different items to.
Oh, different items. So when you are doing an experiment, you need to be very specific on what materials you're using. They said here that they used they made a stone tool out of the stone found in the region. What exactly did they use? Did they just go outside and grab a stone from outside? No. We would need to know exactly what stone tool they made, how it was made. Was it really sharp? Was it just like a circle rock that they were pounding on? Did they sharpen the end? Which type of stone is it? Different stone is softer or harder. So we would need to know exactly what stone they used to make that stone tool. It would make a difference in our results. Because we are different people, we do use different things. We have different things available to us. But if you're going to recreate somebody's experiment, it should be specific enough so you know exactly what to get. If somebody is doing an experiment with the Alka-Seltzers and pop and how much it fizzes, we would need to know exactly what kind of pop they used, because Sprite might fizz differently than Coca-Cola. So you would need to know exactly what type of pop they use, exactly how much pop they use, what container, the size and shape of the container that they put it in. Because if you put some pop in a small little Dixie cup versus pop in a big 2-liter bottle, you might get a different result. So when you're doing your experiment, it needs to be very specific. So somebody else, doesn't matter where they are, somebody in Italy could do the exact same experiment that we're doing here in Minnesota. Your materials should be that specific. Something I talked with the other class about that I'm going to talk a little bit more with Mrs. Gregory about, because science experiments is coming up in history class, social studies. I saw on one of our posters in the hall from one of the people running for class rep is that they want to bring science fairs to St. Vincent's. So this is something that I helped with at my old school, and I've done it several different ways. We've done it where the science experiment was part of science class. Last year we also did it where it was an after school extra activity that people wanted to do after school. And it was a part of the Archdiocese STEM Fair, the Big Bang STEM Fair that they have. And so I want to check to see how many people in here would be interested in doing a science experiment. So we have some interest in here, people saying, hey, that would be pretty fun to do. Some people aren't quite sure. So that's something that I am going to talk with Mrs. Gregory about to see if we can make that an opportunity. She said the last couple of years with COVID, it was really hard. I see some people are a little scared about doing a science experiment. Science experiments can be fun. You get to pick something that you're interested in, and you get to say, this is a question I have. How can I test it? So it's not like we tell you you're going to do this experiment. You get to choose the experiment so you have an interest in it. And then we help you figure out how to set up your experiment so somebody else would be able to recreate it. So somebody in Italy could do this exact same experiment that you do and get the same results. So this is something I'm going to check in with Mrs. Gregory to see if maybe we could do a science fair here and see if anybody could go on to the Archdiocese Science Fair. which was really cool because last year one of our students actually won, I think, third place. It was either second or third place in the whole archdiocese.
Wow.
So that's pretty cool to be able to do that. And I would like for people to be able to have that opportunity if we're able to do it here at St. Vincent's. Kira.
If you do the science fair, do you have to do it?
It depends. Like I said, in the past, I've done it two different ways. One, it was a part of class, so it was graded, so everybody had to do it. You could do it individually or with a partner, so you could pick a friend to do it with. Another way that we did it, because last year things were so different with COVID, was people did it on their own and we met after school. So then it was optional and you could choose to do it or to not do it because it was for your own enjoyment. And people had a lot of fun with it. So I don't know what the science fair, the Big Bang Science Fair for the Archdiocese is going to look like, to see if it would make sense to do it in class or just to do it optional after class. Katie?
Yeah, I also remember, like, when I was in kindergarten, my sisters were homeschooled from high school, and they used one of those humongous bottles of pop and put it into them, like, can I drink that? And then, no, you better back away. And then they put the Mentos in.
Yeah.
Do you still want to drink it?
Yeah, there's some fun experiments that we could do. Okay, we're going to stop the recording here.